Write the partial fraction decomposition of the given rational expression. So we have x squared over x minus 5 squared times x plus 3. And we see that in the denominator we have a repeated linear and a non-repeated linear. So we have to have a denominator for each of the successive powers of that repeated linear. So we have to have one for x minus 5 and one for x minus 5 squared. Now, since they're linear, then we'll have constant a and b, constant numerators, and x plus 3 is also linear, so it will have a constant numerator. So what we'll do is we'll multiply both sides by the lowest common denominator, which will be the x plus 5 squared x plus 3. We're going to multiply that on both sides so that the denominators cancel out. So we have x minus 5 squared, x plus 3 on the left, and x minus 5 squared, x plus 3 on the right. And of course what's going to happen is we're going to distribute this thing here. And in the first term, one of the x minus 5's will cancel. We'll be left with a times x minus 5 by x plus 3. And in the second term, the x minus 5 squareds will cancel. So we have x plus 3 times b. And in the last term, the x plus 3's will cancel, and we'll just be left with c times x minus 5 squared. And then multiplying that out, we wind up with what we have here. X squared is a times x squared minus 2x minus 15 when we multiply this. And then we can multiply through by b, and then we can multiply out the x minus 5 squared. Now, we'll multiply through by x, and we'll have ax squared minus 2ax minus 15a. And I'm going to go ahead and line up terms here. So in other words, we'll have a plus bx plus 3b. So I'm going to put the bx here with the minus 2ax, and then the plus 3b with the constant minus 15a. I'll do the same thing when I multiply through by c. So we'll have plus cx squared minus 10cx plus 25c. And now this is going to give us a system of equations, because all we have in terms of quadratic terms over here on the right is ax squared plus cx squared. And if that's equal to x squared with an understood 1 out front, that tells us that a plus c must equal 1. And then we have minus 2ax plus bx minus 10c over here on the right, but we have no linear term over here. So that tells us that the linear coefficients, minus 2a plus b minus 10c, must equal 0. And then the same thing with the constant coefficients. There's no constant term on the left, so those constant coefficients, minus 15a plus 3b plus 25c, must equal 0.
We have the system of equations a plus c equals 1, minus 2a plus b minus 10c equals 0, and minus 15a plus 3b plus 25c equals 0. This system of equations can be written as a matrix. We will use the coefficients on the variables and the right side of the equations to write this matrix. The coefficient on a in the first equation is 1. There is no b as there are in the other two equations, so that means that that coefficient must be 0. The coefficient on c is 1, and then the right side of the equation is 1. Then for the second equation, we have minus 2, 1, minus 10, and 0. And for the third equation, we have minus 15, 3, 25, and 0. So what we have done here then is constructed a matrix that has 3 rows and 4 columns. So it is a 3 by 4 matrix. We always go rows by columns. So 3 rows by 4 columns. We can use the TI graphing calculator to solve this equation. We'll do that by pressing second matrix. And then what we want to do is edit a matrix. So we'll go over to edit, and we can choose one to edit. Let's just use matrix A, so we'll press 1. The first thing that we'll need to do is define the dimensions of this matrix. Now we decided that this one had 3 rows, hit enter, and then 4 columns, hit enter. Now our matrix on the screen will be a 3 by 4 matrix. So what we'll do is enter these values, 1, enter, 0, enter, 1, enter, 1, enter. Now we have the first row entered. Then we'll enter all the others. Then we'll want to get out of this matrix by clicking second quit. Now we want to get the calculator to solve this matrix for us. And we'll do that by pressing second matrix and then going over to math and then finding the RREF function and hit enter. Now we have to tell it which matrix we want it to do this function on. And we'll do that by accessing the matrices again. So we'll click second matrix. And then we'll leave it on this menu names. And it was matrix A that we entered all of our values in. So we'll push 1. So now we have this RREF function that's going to solve the matrix A, and then I'll close that parenthesis and hit enter. And there we go. Now, remember where all of the entries in this matrix came from. The first column represents the coefficients on A. The second column represents the coefficients on B. And the third column represents the coefficients on C for each of these equations. The fourth column would be what's on the other side of the equals sign. What the calculator did was perform operations with this system of equations that eliminated variables. And so what we're left with is the first row says that when the coefficient on A is 1, the coefficient on B is 0, and the coefficient on C is 0, then what we have is 0.859375 on the right-hand side of the equation. So in other words, A is equal to 0.859375. When the coefficient on A is 0, the coefficient on C is 0, and the coefficient on B is 1, then what we have on the right-hand side of the equation is 3.125. So B is 3.125. When the coefficient on C is 1 and all others are 0, the right-hand side of the equation will be 0.140625. So C is equal to 0.140625.